Evening, sir. Myself, Bhuvan. I am from Anantapur. Currently pursuing my bachelor's in civil engineering at SRET. Today, I am going to explain a deflection problem using strain energy method. Determine the deflection under the load 60 kilonewtons in the beam as shown in figure using strain energy method. We can see that the total span of the beam is 8 meters and the load is at a distance 4 meters from both ends A and B, and the load is exactly acting at its center, and the flexural rigidity is EI, and for AC member. For BC member, flexural rigidity is 2EI. Given a simply supported beam of 8 meters span and a point load 60 kilonewtons is acting at its center, left half rigidity is EI and right half rigidity is 2EI. Support reactions. By taking moment on A, Ma equals to 0 as minus RB into 8, because negative is it is acting anti-clockwise, and plus 60 into 4, the load is acting clockwise to respect to point A. Minus RB into 8 plus 60 into 4 equals to 0. RB into 8 equals to 60 into 4, and RB equals to 240 by 8. 8 3 are 24. RB equals to 30 kilonewtons. Reaction at B is 30 kilonewtons, and moment on B, moment at B equals to 0. Ra into 8 minus 60 into 4 equals to 0. Ra into 8 equals to 60 into 4. 6 4 is 24. 240 by 8. Ra equals to 240 by 8. 8 3 are 24. So reaction at A is 30 kilonewtons. Moment for AC member. Moment is load into perpendicular distance. Moment for AC member is Ra into X. That is, we can do this problem without using reactions. Similarly, for BC member, moment equals to RB into X. We divide the beam into two halves, from A to midspan, from B to midspan. In both cases, bending moment M equals to reaction into distance. Only EI changes in right halves. Let the distance from A to X, M1 equal to reaction at A into X. M1 equals to the load is acting at its center for a simply supported beam. So reaction will be half of its load. That is Ra equals to P by 2. M1 equals to P by 2 into X. By using strain energy formula, U equals to integral m square by 2EI into dx. We can analyze this beam. Un equals to integral 0 to 4 into P by 2 x whole square by 2EI into dx. That is integral 0 to 4 P square x square by 8EI dx. P square by 8EI into integral 0 to 4 x square dx. Integral x square dx is x cube by 3. Un equals to P square by 8EI into 64 by 3. It is equals to 8B square by 3EI. Let the distance from B to X. For the member BC, moment is RB into X. RB is half of its load, P by 2 into X. Here the flexural rigidity is 2AI. Strain energy in the right half, U2 equals to integral 0 to 4 P by 2x whole square by 2 into EI into dx. U2 equals to integral 0 to 4 P square x square by 16 EI into dx. U2 equals to P square by 16 EI into integral 0 to 4 x square P square by 16 EI into 64 by 3. U2 equals to 4P square by 3EI. By adding both strain energy values, total strain energy is 8P square by 3I plus 4P square by 3I is 4P square by EI. Strain energy, total strain energy is. We know that external work done equals to internal work done. work done by external load equals to half into load into deflection, that is equals to 4p square by EI equals to half into load into deflection. S equals to 8p by EI. 8 into load is we know that the load is 60 kilonewtons. 80 into 60 by EI. 8 60 are 48. 480 by EI. Deflection under the load is 480 by EI in downward direction. Thank you, sir, for giving your time.